In this video, we will be solving a problem involving inverse of a matrix. The problem: find the inverse of matrix A with entries 1, 0, -2, 0, 2, 1, and 0, 0, 1 using elementary matrices. To get the inverse of our matrix A, we will follow the steps. Finding the inverse of a matrix by Gauss-Jordan elimination. So let A be a square matrix of order n, then follow these three steps. First, write the n by 2 n size matrix that consists of A on the left and the n by n identity matrix I on the right to obtain the matrix AI. This process is called adjoining matrix I to matrix A. Step 2. If possible, row reduce A to I using elementary raw operations on the entire matrix AI, then the result will be the matrix I A inverse. If this is not possible, then it means that A is non-invertible. Third, check your work if it's correct by multiplying A times A inverse or A inverse times A should equal to identity matrix. Alright, let's use the steps to solve the problem. Step 1. Adjoin matrix I to matrix A, meaning place all the entries from these two matrices in one matrix in this order. Matrix A on the left and identity matrix on the right. Step 2 tells us that in order to get A inverse, we need to turn this matrix A side into identity matrix by performing elementary row operations on the entire matrix. And if we get a matrix A side become identity matrix, then this side here will turn to be our A inverse. Again, we will perform elementary row operations. So first, we will work with this number. Our goal is to turn this number into 1. And to do that, we will multiply the second row, the entire second row by 1/2. If we will multiply that, we get a new second row. So 1/2 of 0 is 0. 1/2 of 2 is 1. 1/2 of 1 is 1/2. 1/2 of 0 is again 0. 1/2 of 1 is 1/2. 1/2 of 0 is 0. We get a new second row, and we just copied the entries from our first and third rows. From here, we have to work in this number and turn this number into 0. To do that, we will multiply 1/2 in our third row and subtract that from the second row. Okay, so 0 minus 1/2 of 0 is 0. By the way, we will do that to obtain the new second row because our goal is to turn this number into 0. So 0 minus 0 is 0. 1 minus 0 is 1. 1/2 minus 1/2 of 1 is 1/2. So 1/2 minus 1/2 is 0. So 0 minus 0 is equals 0. So 1/2 minus 0 is 1/2. And 0 minus 1/2 equals -1/2. So this is now our new second row, and we turned this number into 0. Now our last goal is to turn this number, this -2 into 0, so we can complete our goal to turn this matrix A side, original matrix A side, into identity matrix. So to do that, we will multiply the third row by 2 and add that to the first row. All right, so 1 plus 0 is 1. So we do that to get to turn this number again. We will do that operation to turn this number into 0 and to obtain a new first row. Okay, so 1 plus 0, 0, 1. 0 plus 0 equals 0. -2 plus 2 equals 0. 1 plus 0 equals 1. 0 plus 0 equals 0, and 0 plus 2 equals 2. Alright, so we got our new first row, and we already completed our goal to turn our original matrix A side into identity matrix. So since we turn this into identity matrix, this side here becomes now our A inverse. So our A inverse is with this entry 1 0 2 0 1 half negative 1 half and 0 0 1. All right. Following the third step is to check if our work is correct. Okay, so we have, if we get the identity matrix as the product of our A matrix times and A inverse, then our work is correct. So here we have our matrix A and we have our A inverse. So if we multiply these two matrices, then we get the product. We get this product, and this is identity matrix. You can check this, and if we check that, if we multiply this 1 times 1 and this 2, and if we add their products, then we get 1. And you can check that too. If we multiply this from here, okay, if we multiply 0 to 1, 1 half to 0, and 0 to negative 2, we get 0. Okay, and if we multiply 2 to 1 and 1 half of 0 and 1 times negative 2, we get zeros. If we add their products, we get zeros. Again, and now on the second row on our product. So if we multiply 1 to 0, we get 0, plus 0 times 2, we get 0. And if we add the product of this, it's another 0, so we get the entry of 0. And for the second entry in our second row, if we multiply 0 to 0, it equals 0. 1 half of 2 is 1. 0 times 1 is equal to 0, so we have the entry of 1. So because 1 half of 2 is 1. Alright, so to get the third entry of our second row, we multiply the third column here from the second row here of our matrix A. So 2 times 0 is 0. Negative 1 half of 2 is negative 1 half, and 1 times 1 is 1. So um, I mean rather negative 1 half of 2 is negative 1, and if we add that 2, we get the entry of 0, because negative 1 plus 1 is equal to 0. All right. And to get the interest to our third rows, to our product, we multiply 1 to 0 equals to 0, and these numbers, and their sum, the product of their, the sum of their products is 0. Okay. And the second entry for our third row, we multiply this 0 to 0. Okay, hold on. Okay, so 0 to 0 is 0, 1 half of 0 is 0, and 0 to 1 is 0. So we get the entry of 0. And 0 of, sorry, so 2 of 0 is 0, 1 half of 0 is 0, and 1 times 1 is 1. So therefore um, we get the entry of 1. So the product implies that since we get the identity matrix is the product by as the product of A inverse times A matrix, therefore our work is true. And the same thing if we multiply the other way, if we multiply A inverse times A, that will also equal to identity matrix. Therefore, our work is correct, and the value of our A inverse is and A inverse is uh, our A inverse is this 1, 0, 2, 0, 1 half, negative 1 half, 0, 0, 1.